anyway. We had yet another round of hardware bugs that caused new sets of changes. I have lost track how many we've had of those in the last decade. It's been a few.
So it's been very frustrating, and it's been frustrating not so much because of the bugs themselves. I got into doing kernels because I'm interested in the hardware. So in many ways, when these security bugs happen in hardware, they're really interesting. They're literally why I do kernels, understanding how the hardware really works and taking advantage of it, but also in the case of the bugs, having to work around them. The thing that then is very, very frustrating is that you have these technically interesting problems, but then they are made to be a horrendous experience by all the secrecy and the fact that you can't work on these interesting problems in the open. Which, I mean, the other part of Linux obviously being it's not just that I was interested in hardware, but I love just the development model where you can talk to people and work on interesting stuff. And the security issues we've had over the last decade have kind of destroyed that for me and have been a huge frustration and a huge negative. And it's kind of sad because it's really just about the process is horrendous, but the challenges would otherwise be pretty interesting.
Well, here is your chance to talk about the next 3 already before the embargo is lifted. No?
No, I can't. It's sad. Actually, I don't think we have.
Don't go there. But so the common pattern of the last many of them, is always these side channel attacks, is always these unexpected consequences of the optimizations in the silicon and how that leads to different timing that allows you to draw conclusions. And so isn't that incredibly fundamental? We now see them finally in Apple silicon because people test Apple silicon more. Is this, we're going to have this forever?
Oh yeah, I mean, a lot of these issues are very fundamental, and that is to some degree what makes them interesting. The problems become, the problems come up not because the CPUs are doing out of order and speculative work, it's because then to software they only expose the architectural side, the side that you're supposed to see, the end result. And then that often makes it very hard to work around for software, the fact that sometimes they speculate and do things that software didn't tell them to do. And almost always the solution to the technical problems is that the hardware then gives us as kernel people, but also as web browser developers, gives us extra knobs to say, in this situation, you need to be a bit more careful. And it's one of those things that as a software developer, it frustrates you because we can often react quite quickly in software, but then the hardware people are saying, oh, we have 5 generations of hardware that we can't fix after the fact. And it will take another couple of years before the actual new hardware that can help you work around the problem comes out. And that ends up being very frustrating with the whole added side of all the PR and that goes along with any security issues.